Welcome to Lesson 3. This lesson is all about writing two-step equations, and basically what that means is we're going to take the English language, we're going to take words and translate them into what I would call the math language. So we're going to use math symbols in order to represent sentences. Okay? Obviously we're going to be doing it with two-step equations, so we're going to be combining either multiplication or division with addition or subtraction. Okay, so basically what we need to do is we need to understand how to translate words like more than, less than, etc. into mathematical statements. Okay, for example, more than, obviously if you have 8 more than another number, we're talking about addition there. A very common mistake is when kids see less than, the words less than, they immediately think of this symbol. And I don't want you to think of that any more than when you look at more than, don't think of greater than. Okay? It's not about that. It's if I have, let's say for example, 5 less than a number, that would be that number minus 5. This is about subtraction. So many of you will have problems with this, so I highly recommend you put it in your notes. Okay? The statement of a number. Well, if I have 5 packs of 10, that's 5 times 10. This is all about multiplication. Okay? So this is multiplication. Let's get rid of this. This is addition. This is subtraction. And obviously, if I have this and this, we're going to add the two things, another addition. If I have 5 times a number, that one's pretty easy. That's multiplication. Quotient is division. I'm going to talk a little bit more about that in a minute. Per item, if things are Big Macs are $4 per Big Mac. So if I use B to represent a Big Mac, $4 would be 4 times B. This is about multiplication whenever you see the word per. We might have some other words that we need to decode as well later on. Okay, so let's move to that problem where we talked about quotient. Here's a good example of quotient. The quotient of a number and 10 is 80. The is 80 should be easy. That's equals 80. So it's a quotient of a number and 10. So it's either 10 divided by a number or n divided by 10. And this is a very, very common mistake. Another thing that would be good to put onto your gold sheet for notes. The quotient of a number and 10 is the number divided by 10 in that order. Not 10 divided by the number. N divided by 10 equals 80 in this particular case. So here we go. Example number 1. Our statement, and notice I'm using numbers here. It just made it easier for me to put these on the board rather than write out a number like 13 or whatever. Okay, so we have 8 less than 3 times a number is negative 23. And what I'm going to recommend is that for most of these, you work them backwards, or at the very least, you look for the easiest piece of the statement to put into math language. Okay, so if we do this one, I would do this first. First, I would say is negative 23. That's easy. Equals negative 23. Okay, next thing I pick is 3 times a number. Well, 3 times a number is quite easy. That's 3n. Okay, and I have 8 less than that 3 times a number. So here's the 3 times a number. I'm going to take 8 less than that. That's subtract 8. So we have 3n minus 8 equals negative 23. Okay, do not, for less than, remember, do not use the less than symbol. It's subtraction. Okay, problem number 2. 3 is 7 more than 1/5 of a number. Again, we can do this backwards. We can say 1/5 of a number. Remember, something of a number is multiplication, so it's 1/5 times n, or 1/5 n. Okay, second thing we can look at is 7 more than, well, 7 more than that number, so here's that number. 7 more than that is plus 7. Okay, and then lastly we have 13 is. So in this case we have the equal sign out front, but we could easily, just as easily, have tacked it onto the end here and said equals 13. It's the same thing. Okay, now do problems letters A through C. Okay, example number 3. Again, this is a word problem and we're going to work backwards. That works well in almost every situation. The last thing they ask you is how much for each book. So we're going to put B equals books because books is our unknown, and we're going to use B to represent that. It also tells us that the magazine is $1.99. So we put that information down. Go back a little further, and it says that we paid for all of them, it was $55.99. So we've got that number there. And lastly, they said that we bought 3 books and they were all equal priced. I didn't put the equal price on here, but we're going to put that as 3B. Notice that's a B, that's not 36, 3B. So we have these 3 figures here. And we understand that the books plus the magazine, okay, 3 books plus the magazine, 3B plus the $1.99 gives us our grand total of $55.99, which is what we spent. And now all we have to do is solve that problem. So moving on to the solution, 2-step equation, we have 3B, or 1 and 99/100ths, equals 55 and 99/100ths. We're going to subtract 1.99 from both sides. Let's make a change here. This is not a 5. Okay, and we end up with 3B equals $54. So obviously we're going to divide both sides by 3 to undo the multiplication of 3. And we have B equals 18, and we can write it as $18 per book. Example number 4. Another word problem. They ask how many weights. So immediately we're going to define a variable. W is going to equal weights. They also tell us that our grand total was $849.86. So it's 849.86, and it's $24.99 per weight. So it is 24 and 99/100ths W times W. And then lastly, we paid $500 for a bench. So if we paid the grand total of $849.86 and we bought weights and we bought a bench, that would be 24.99 times the W will give you the amount we paid for weights plus the $500 that we paid for the bench. And that it gives us a total of $849.86. And again, it's all about just solving the problem. 2-step equation, we undo the addition first by subtracting 500 from both sides. We get 24 and 99/100ths W equals 349 and 86/100. Divide both sides by 24.99 and you get a grand total of 14. In the sentence we would say 14 weights were purchased. Okay, please press pause and do problem letter D. Okay, here are the solutions to the letter problems for lesson 3. For letter A, we have the problem 15 equals 3 more than 6 times a number. So I've circled the individual pieces of the sentence. The key here is you really don't have to do it in any particular order. Like I said earlier, you could take whatever you think is the easiest thing to do. For example, 15 equals, that would be equals 15. Or you could do it this way, 15 equals, and start it out that way. Both of these equations end up being the same. It's just a matter of how you show them. Then so far as 3 more than is an addition statement, and of course 3. And then 6 times a number would be 6, in this case 6n. You can use any variable you want. So you would have 6n plus 3 equals 15, or you would have 15 equals 6n plus 3. The same answer. For problem letter B, we have 10 increased by the quotient of a number, and 6 is 5. Again, solution is 5 is equal 5. 10 increased, well, an increase is obviously an addition statement, so it's 10 plus. And then the quotient of a number, and 6. A quotient is a division, a number, so it's n divided by 6. Now if this said quotient of 6 and a number, then you would reverse it and it would be 6 divided by n. The key thing to remember with division and subtraction is order does matter. In multiplication and addition, order does not matter. 5 plus 5, that's a bad example. 6 plus 5 is the same as 5 plus 6. 5 times 6 is the same as 6 times 5, but not in the case of division or subtraction. So be careful, make sure you have it correctly. Letter C. here's going to be an example of subtraction. The difference between 12 and 2/3 of a number is 18. Is 18 equals 18. 2/3 of a number, 2/3 times n, or any other variable. And the difference between 12 and that number would be 12 minus 2/3 n. If it was the difference between 2/3 of a number and 12, then you would flip these. But be careful. Letter D. Word problem. At the end they ask how many hours, so we're going to use h as our variable to stand for hours. They also say when will it be 84 degrees Fahrenheit. So 84 degrees Fahrenheit is your result, so that tells you that something is going to equal 84. We have a rise of 2.5 degrees Fahrenheit every hour. So whenever we're talking about per hour, we're talking about multiplication. So it's 2.5 times the hours is the expression for that piece of the statement. And then lastly, or actually the first thing they said was the current temperature is 54. So we're going to have the current temperature plus this change in temperature is going to give us this result. So we have 2.5 times the hours plus the starting temperature of 54 equals 84 degrees. And then of course we just need to solve that. So we've got 2.5h plus 54 equals 84. Undo the addition by subtracting 54, and we get 2.5h equals 30. So we're going to divide both sides by 2.5 since this is a multiplication statement here, and we end up with 12. So your statement would be, it will be 84 degrees Fahrenheit in 12 hours. Please do the guided practice.